Hello my dear students. In this video we are going to derive a interesting and very important derivation, that is derivation of orbital velocity of a satellite. Okay. On this satellite, when this satellite is revolving around the earth, on these satellites there are two forces which are acting. One is centrifugal reaction which is acting in this direction. Means whenever any particular object is moving in a circular track, there is a centripetal force acting on it towards the center. Centrifugal reaction is acting always outwards, correct? Now at the same time, some gravitational force is acted on this satellite due to the gravitational attraction between earth and satellite. Means earth is pulling the satellites towards its center. Okay. Now if, say for example, if the centrifugal reaction is more, then the satellite will go out of the orbit. Okay. Then it will escape from earth's gravitational pull. If the gravitational force is more, then the satellite slowly comes and falls into earth's surface. If the satellite has to move in one particular orbit, one particular circular orbit around the earth, then centrifugal reaction should be equal to gravitational force. So therefore, my first step should be centrifugal reaction should be equal to gravitational force. Remember, if the centrifugal reaction is more, then the satellite will escape. If the gravitational force is more, then the satellite will fall into Earth's surface. So therefore, if the satellite has to continue in a circular orbit, fixed circular orbit with fixed velocity, centrifugal reaction should be equal to gravitational force. Okay. Centrifugal reaction should be equal to gravitational force. Okay. What is the equation for centrifugal reaction? mv square by r. mv square by r. I write it as VO. VO stands for orbital velocity. So that is equal to, what is the gravitational force of attraction between these two? Let us suppose that mass of the earth is me, mass of the satellite is m. Okay. So gravitational force of attraction between the two is g into me, mass of the earth, into mass of the satellite, divided by square of the distance between them. Okay, what is the distance between them? Say satellite is at a height h from earth's surface. And what is the radius of earth? Radius of earth is re. So what is the total height? What is the radius? Re plus h. Okay. Re plus h whole square. So here also I can write, in the place of r, I can write re plus h. This is also re plus h. Correct now? Now what happens? Mass of the satellite gets cancelled, right? One re plus h and one re plus h gets cancelled. So what we get? VO equal to VO square equal to GME divided by RE plus H, or VO equal to square root of GME divided by RE plus H. What is this RE plus H? It is the radius of the circular orbit. So this is the equation for orbital velocity. Okay. Here we can do some approximation. Say the satellite is very close to the surface of Earth. So this is the equation for orbital velocity, remember. Okay. If there is one small final step. Okay. If the satellite is very close to the Earth's surface, then what happens? This h is very, very small. I'll write here. Orbital velocity is equal to square root of GME divided by RE plus H. If satellite is very, very close to Earth's surface, then h is very, very small compared to re. Correct now? Hope you can understand. If the satellite is very close, okay, then re plus h will become equal to re only. So therefore, then what happens? Re plus h will be approximately equal to re only. So then what happens to this equation? This equation implies VO equal to square root of, what is GME? GME means G into RE square. Correct now? Because we know the equation G is equal to GME divided by RE square. Equation for acceleration due to gravity on Earth's surface. So therefore GME equal to GRE square. Okay, GRE square divided by RE plus H is approximately equal to RE itself. What happens? One RE gets cancelled. So orbital velocity equal to square root of GRE. This is true only when h is very, very small. Okay. If you substitute the values, you are going to get approximately orbital velocity is equal to 7.8 kilometers per second. 7.8 kilometers per second. So if you try to remember, escape velocity of Earth should be more than that. It is 11.2 kilometers per second. Okay. What is this 7.8 kilometer per second? It is the orbital velocity of a surface satellite, or it is the orbital velocity of a satellite which is close to the surface of Earth. Okay. Otherwise, what is the general equation for orbital velocity? General equation is square root of gme divided by re plus h. Hope you understood this derivation. Thank you very much.